Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video for you. All math-based, of course. And look, I've got the Yule log in the background. Or something like that. I just found it on YouTube. So, I'm going to be doing a lot more practice problems with you here. 20, in fact, solving inequalities. The first 6 are going to be writing out inequality statements based on a word problem. And then the other ones, I'm just going to, just like solving equations, solve the inequalities that often uses distribution, combining like terms, some fractions here and there, and graphing them. And I'll show you some of the tips and tricks along the way, but to make it as fast as possible, I think once I teach it some of the first few times, I just want to start just going over the problems after that, if that's okay with you. So without further ado, because it's Saturday night, I just came from, I coach softball, just came from some stuff there. Without further ado, let's go ahead and get started. Now the first 6 problems on this page here are we are going to write an inequality that represents the description. Oh, and then I guess I will solve, if that's okay with you. Some of them are set up exactly as like they're solved once they're set up. Max has more than 5 carrots. Number of carrots Max has equals C. So they define the variable for us. So here's how these things go down. There are 2 expressions in this thing. Whether there are a lot of terms or just a single term is whatever. But there are 2 expressions in each of these things, and we are comparing them. Now, Max has more than 5 carrots. So there is somewhere here, there are 5 carrots hanging out. Here are the number of carrots that Max has. He has more than 5 carrots. So what we're going to do is represent that with the proper inequality symbol greater than, facing the C right here. Max's number of carrots is greater than 5. And it's also solved for now that we're there. I'll graph the other ones later. I'll just go ahead and do these ones on their own. That's it. Number 2, Bridget is shorter than 5 feet. Bridget's height equals h. Okay, so we're comparing Bridget's height h to 5 feet here, and Bridget's height is shorter, therefore it is less than. It is not equal to, just less than. And that would be the solution right there. So sometimes they're set up, I like how they set it up very easily to start with. I don't want to do a video with hiccups. We'll see what happens. Number 3, twice a number, x, is less than 10. So what they're saying is compared to the number 10, if I take a number and twice it, I double it, if I multiply it by 2, it still happens to be less than that 10 right there. This number could be 4, and when I double 4, it's 8, which is less than 10. That's just the idea. And of course, always try and use a real number to make sense of it if you're having trouble. That seems to work out. Number 4, 6 more than 5 times a number is at least 21. Okay, so let's start with the 21 on this side because that's easy to write. Something is at least 21. So what does at least mean to you? To me, it means that it can be 21 or it can be more than it. So we're looking at something over here that's going to be greater than or equal to 21. Now, how do we write that expression? This says 6 more than 5 times the number. And of course, if you have trouble with it, try a real number. Let's make this number 2 instead of a number. Let's call it 2. What is 6 more than 5 times 2? You do 5 times 2, and then you add 6 to it. So same with this thing here. We do 5 times some number x, and then we add 6 to it, and that will happen to be 6 more than 5 times the number. And this is at least 21. Okay, so the number 3 would work here, because 5 times 3 is 15, plus 6 is 21. So it's at least 21. It is 21. Stuff like that. All right. 2 more. These are kind of bigger. Dave has $15 to spend on an $8 book and 2 birthday cards for his friends. How much can he spend on each card if he buys the same card for each friend? Okay, so, I mean, look, you can come up with the answer on your own, but the point is to set up the inequality to solve for it. Keeping in mind, it's an inequality, not an equation. He doesn't have to spend all of his $15, and that's the biggest point that I want to make with this. He could spend his $15 he could spend up to his $15, but 15 is the absolute maximum. So at most he could spend 15. He could spend 15, or he could spend less than 15. And that's how this thing is an inequality. 15 is his total number of dollars, But on the other side here, we have a less than or equal to with this thing here. He could spend $14, which is less than or equal to 15. He could spend $15. He couldn't spend $16 though, because that exceeds his $15 amount. Hopefully it makes sense why we're setting it up as an inequality and why it goes this specific way. All right, he has an $8 book. That is a constant value. He's only buying one book. We know how much it is. It's not going to change no matter how many birthday cards he spends. So we know that no matter what the birthday cards are here, we're going to add $8 to the overall amount. If you're thinking about the math already, that would mean he'd have $7 left to spend, and you're probably working ahead. But 2 birthday cards, C equals the number of birthday cards. Excuse me. It doesn't. C equals the cost of each birthday card. He's going to be buying 2 birthday cards. And if you saw the word problem translating situations into equations video, then you know what I do with those as well. You take 2 birthday cards times the cost of each birthday card, C, and this term equals the total amount of money spent on all 2 birthday cards, on both birthday cards. So this is the inequality. 2C plus 8 is less than or equal to 15. Okay, now how do you solve these things? You solve them just like you would solve equations. Treat this thing as like a barrier that we shall not pass unless we cross things over through some form of math. Like if I subtract 8 from both sides here, that starts to isolate my C term. And then I will now have 2C is less than or equal to 7. And if I divide both sides by 2 here, that's where you get your C is less than or equal to 3.5. Now, when it comes to the context of the problem, because it is a word problem, I'd rather write this thing a little better, and I'm going to. In fact, I'm going to type it out, and I'll drag it somewhere else here in a bit. But Dave can spend, let's make that smaller. Dave can spend up to $3.50. See, those are the units. That's C for each birthday card. Keeping in mind, he's going to be spending the same amount for both of them. Okay, so that's Dave's whole thing there. I'll leave that down there. Great. Asked like a word problem, or asked in a sentence, answered in a sentence. All right. Last one. Tony can carry up to 18 pounds in her backpack. Her lunch weighs 1 pound, her gym clothes weigh 2 pounds, and her books weigh 3 pounds each. How many books can she carry in her backpack? Okay, so the same thing as before. She can carry up to 18 pounds. Up to, just like the can spend, he has $15 to spend. Up to 18 pounds, meaning 18 is the max, and that's the weight of her, or that's the weight capacity of her overall backpack, and that's the most. So you can put less in there, or the same amount. So what we do have are some constants here. Her lunch that weighs 1 pound, heavy lunch. Her gym clothes that weigh 2 pounds, and her books that weigh 3 pounds each. If you take 3 pounds per book and multiply by the number of books, your total is going to be some weight in pounds here. So here's the setup of this inequality. 3b plus 2 plus 1 is less than or equal to 18. I'm going to combine like terms first, and then I'll move some stuff over. Okay. Subtract 3 from both sides. I'll just not show the work there. 3b is less than or equal to 15, and divide by b. b is less than or equal to 5. Now keep in mind, these are the number of books. So you would only really be looking at integer values. B can be 0, 1, 2, 3, 4, or 5. Oh, right, I counted 0 as 1. 0, 1, 2, 3, 4, or 5 books, not 4.5, whatever, if each book weighs 3 pounds. So she can carry, who is this, Tony? Maybe it's a he. She. Tony with an I. Tony can carry up to 5 books in her backpack. Backpack. There we go. Sorry, this is kind of a rough and loose video. I'm doing this on a whim. I promised my students that I'd get it done, and I'm kind of, it's not going great, but I got 14 more problems to do. They're all going to be solving, and I'm going to be graphing them, but hopefully that's kind of making sense there. All right, here we go. So the next 14 problems here, solve each inequality, and let's graph them too. Graphing means putting them on a number line. I'll show you how I do it and what it can help you double check with And for the most part, I'm going to be doing double checking until I finally give and say, it's good, let's move on. Okay, 3 times the quantity x minus 2 is greater than negative 3. Let's find out what x values work for this. Now that's how inequalities work. The whole point is x can be an infinite number of solutions. It can be greater than or less than or whatever, this certain amount, and that's all we're getting with it. But we represent it with that symbol. I'm going to start by distributing. There's another way I could do it by dividing both sides by 3. Sometimes people don't recognize that with the multiplication, so I'm just going to distribute. Something I have to practice with, my classes anyway. So multiply the 3 by x by negative 2. I get 3x minus 6 is greater than negative 3. I'm going to add 6 to both sides. Mind the single color form I go with here. Negative 3 plus 6 is 3. So 3x is greater than 3. So what this is saying here is if I multiply 3 by a number, it's got to be greater than 3. So the value for x that's going to make this work, if you divide both sides by 3, you'll see it even more easily. X has to be greater than 1. So that's the solution. Now what I want to do is I want to graph my solution. I'd like to represent this thing on a number line. So here's what I'm going to do. Draw myself a very small number line here. It's how they're all pretty much going to look. What I'm going to do is I'm going to place 0 on this number line. Now 0 is not my boundary point in this case, and in most cases I kind of hope it's not, so I can show you something with it. But 0 is my boundary point. Excuse me, is not my boundary point. It's the threshold between positive and negative. 1 is my boundary point right here. So I'm only going to place these two numbers. I'm always going to place 0 and the boundary point. And if 0 is the boundary point, then that also works. 1 is the boundary point, and I'm going to draw an open circle because this is greater than only. It does not include 1. If it included 1, I would close it in like that, but I'm not going to. And I'm going to go ahead and draw an arrow to the right side to represent the fact that x can be any value over here. X can be 2, x can be 7, x can be pi, x can be a billion. But if I take a billion and place it in this inequality, I will make a true statement. And that's the whole point of what we're doing here. We're trying to see what values of x will make this statement true. The left side greater than negative 3. So apparently any number greater than 1 will work. Now here's what I like to do for double checks, and this is assuming you did the math right. This is more a question of which way does this inequality go. Notice how I've shown the greater than, and greater than. The sign will actually change when we multiply or divide by a negative. And in this case, I'm just going to show you how it looks to double check. And then I'll do it once I finally multiply or divide by my first negative. If x is greater than, let's see, how do I want to say this? If x is greater than 1, that means that only these values can work as solutions. I like to do a double check with at least one number, and my favorite number to check with is 0. 0 because I know exactly where it fits on this thing because I wrote it. And because normally when I substitute it into here, it makes the math very easy. Now, I do not expect 0 to be a solution in my inequality. That means when I substitute 0 into here, I expect a false statement, and that's a good thing for me. Is it always false? No, it depends on if this x includes 0. This one doesn't. So I'm going to go ahead and try and place 0 into here mentally and see what happens. Actually, I'll write it this time. Other times I'll do it mentally. Let's do 3 times 0 minus 2 is greater than negative 3. And you can see easy calculation. That's negative 2. And 3 times negative 2 is negative 6. Negative 6 is greater than negative 3. Is that true? No, just because the absolute value is bigger. Negative 6 is not bigger. Negative 6 is further to the left. No, that don't work. And that's a good thing. I didn't expect 0 to be a solution, and it wasn't a solution. And if I got my boundary point right, I'm guessing I also graphed this the correct way. Okay. So I'm going to do those faster when it comes to it. That's just you seeing it for the first time. Let's go ahead and do number 8 together. And of course, there's more than one way to do these. I could show you the second way. I'll find one to do a different way with, maybe with this fraction one. I think that sounds good. I'm going to distribute this right here. I have 5 plus, distribute this, 5x plus 20. That's going to be less than or equal to 20. Okay, 5 plus 20 can combine. That gives me 5x plus 25. That's less than or equal to 20. If I subtract 25 from both sides, it's gone here, and 20 minus 25 is negative 5. So all that's left on this side is 5x, subtracting 25 from that side. Subtracting 25 from this side, I have negative 5. And I divide both sides by 5, and I'm only saying that because I don't have room to write it if I'm going to do my number line graph. X is less than or equal to negative 1. Again, notice that I left this as less than or equal to the entire time, that I didn't do any other sort of manipulations. One of them is dividing by a negative, and you'll hear some other ones from me in the future. Okay, so let's graph this by drawing our number line again. Let's place 0 here. Let's place our boundary point where it's supposed to be, to the left of 0. X is less than or equal to, which means I create a solid, filled in, closed circle, because negative 1 is included in my solution set, and less than means left, right here. Any of these values will hold true. 0 should not hold true. Let's try that. 0 plus 4 is 4. 5 times 4 is 20. 5 plus 20 is 25. Is 25 less than 20? No. Is it equal to 20? No. False statement. That's a good thing because that's what I anticipated. I guess this worked out well. Okay. Number 9. 3 plus 1/2 times the quantity 3 minus x is less than negative 7. Now, here's where I'm not going to distribute, and hopefully you're going to kind of make sense of this right here. If I distribute that 1/2, I'm just leading myself with more fractions. If I was taking half of even numbers, then I get integers, and then I don't mind that. But half of an odd number 3 and half of an odd coefficient negative 1 is just going to lead me to more fraction stuff. So I'm actually not going to distribute this one first. You may, and you can get the right answer. I'm not going to. So instead, I'm going to do this. Check this out. I'm going to go ahead and subtract this 3 over because I know there's no x terms out here that I have to combine. And I know that this can help me combine with this negative 7 here. I might as well just subtract negative 3 from both sides to begin with. Nothing wrong with that. No problem. 3 minus 3 is 0. Here I have 1/2 times the quantity, 3 minus x. This is less than negative 7 minus 3 is negative 10. Okay, I mentioned I won't distribute the 1/2. So what I'm going to do instead is clear this fraction completely. I don't want it. And I can't just say like, hey, let's erase it. Yeah, da, 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 da. No, I can't do that because I have to make sure whatever I do to one side, I do to the other. Not like, let's erase this, let's erase this. More like, if I double this number, if I multiply both sides by 2 right here, in fact, I'm going to say 2 over 1 because I want you to get into the idea of reciprocating your fractions, if that's a word. This can now cancel out 2 over 2, which is 1, 1 over 1, which is 1. It can get rid of my fraction completely. And all I have left is a 1 out here that multiplies by 3 minus x, and that just becomes 3 minus x. So the fraction is gone. But the right side also doubles. Negative 10 times 2 is negative 20. There, that's a much better look for my fraction, or my inequality. Now, I could have multiplied by 2 from the very beginning here, but I caution you of it because you'd have more than one term to multiply into, and you'd have to distribute into that, and you'd question whether you have to distribute into there afterward. It was just easier to subtract the 3 first, in my opinion. Okay, now I'm going to subtract 3 again from both sides right here, and here I'm going to get negative, keep in mind, this is a negative right here. Negative x is less than negative 23. Okay, let me do something quick. I'm going to group this and shrink it some so I can get myself some more room. Hey, look what just happened. My 2 over 1 kind of didn't go. Negative x is less than negative 23. Now, if I multiply both sides by negative 1 here to make my x positive, as I would with an equation, then you would get negative x here, or excuse me, positive x here, and then positive 23. And let's say, I'll humor you here, let's say as I put it in red that I kept this as less than. Okay? X is less than 23. If negative x is less than negative 23, then x is less than 23. Does that work? Let's go and graph it on a number line. I'll place 0 on here. Whoops. Place 0 on here. Here's 23, wherever. Cool. Now, x is anything that's less than 23. So here, open circle, not including 23. And let's go to the left here with this arrow, and all these numbers can represent x as a solution to the original inequality. Now let's see if this works. If it does, notice I'm going to try 0 again. I love choosing 0. 0 can plug things in very cleanly and work all this stuff out. And I anticipate a true statement to happen because 0 happens to be one of the solutions of my inequality. So let's try 0 here. 3 minus 0 is 0. Half of 3 is 1.5. And 3 plus 1.5 is 4.5. Is 4.5 less than -7? Heck nah. No. 4.5. It's less than 7, but not -7. Uh-oh, something went wrong. We're on the wrong side of our boundary point here. Okay, something weird happened. And this is where the inequality flip has to occur. So I'm going to go ahead and flip this thing and say greater than, and suddenly this statement should be working out just as is, which means I also have to do something with this guy here. I'm going to go ahead and rotate it over like that, if that's okay. Let's see, I can flip it upside down too. How do I do this? Flip up and down like that, whoop, and it's going that way now. So there goes x, all the way over there, that's fine. 0 is not a solution, and that's good. It shouldn't have been. It shouldn't have been, and it wasn't. Now why does it flip? I'm not going to speak too long on this. Just why does it flip? Think about what happens when you multiply by a negative. Your distance from 0 remains the same with your values, only now it goes on the other side of it. Let's try these numbers here. Is 5 greater than 4? Yes, 5 is greater than 4. But let's multiply them by -1. Is -5 greater than -4? No. -5 goes on the other side of -4, so it becomes less than once it crosses 0 that way. 5 is greater than 4. -5 is less than -4 because how it compares to 0. Think of it, have you seen, this is dumb, it doesn't actually qualify, but have you seen that SpongeBob episode where they go pirate treasure hunting because Mr. Krabs is just weird? He brings on, like, it was the game board thing and he thought it was a real treasure, and I think it was, whatever. But anyway, Patrick has the compass and he leads them 10,000 paces east, so to speak. And Mr. Krabs, what? Where is it? I could have sworn 10,000 paces east. And he's like, oh, east? I thought you said west. He's like, that's west, Patrick. So they went 10,000 paces west. They went 10,000, let's see, what's west for you? This one. They went 10,000 paces west. Now compared to someone who only went 5 paces west. Okay? Now let's say they said, oh, both of you guys went the wrong way. You weren't supposed to go west. You weren't supposed to go Wow, you weren't supposed to go west. You were supposed to go east. I was trying to say east. You weren't supposed to go west. You were supposed to go east. So they're like, okay. So this person has to go 10,000 paces east. And this person has to go only 20,000. This person has to go back to 5 paces east over here. Now, in this scenario, this person is further west than this person. However, when they have to redo and go back this way, this person is farther east than this person is now. I'm over-explaining this. I know I am. But some people don't get it. And that's why when dividing or multiplying by a negative that happens. Because no matter what, you change the signs of what you have. Now, I am going way over long for this thing. I still have 11 more problems to do. So I think I'm going to speed this one up. But I am going to show you different problems where you might try a different route, but I have to caution you of something else with that other route as well. So let's keep going. This time I'm going to speed up more through the math. If you have questions on the math, pause it. But this is where I get myself in trouble. I talk too much. No, I talk a lot. I don't talk too much. There's never too much talk about this stuff when people don't get it. That's why I do it. I hope people understand it. Okay, distribution here. Now distributing the -2, caution, it's a -2, -2 times x, and -2 times 2. That's a -4 right there. So this is greater than or equal to 10. Combine like terms. 3x minus 2x is 1x. 18 minus 4 is 14. X plus 14 is greater than or equal to 10. Subtract 14 from both sides. X is greater than or equal to -4. Let's box that answer. Let's go ahead and graph that fast. So for some of the problems, I don't have much to explain. I'm just going to say how I did it, and that's it. I'm not going to double check any other ones that don't have to, do with a sign flip or this. The one other thing, it's the most embarrassing video I've done. So x can go that way, greater than or equal to -4, and it should work even with 0. I have hiccups. Number 11. Let's see if I can just write some things on this one and see where I go from here. While I hold my breath. Okay, I'm going to let go of holding the breath there. Negative times a negative gave me a positive. That's why it's positive. All right, combine like terms. Negative 5x plus 12x, positive 7x. 15 minus 8 is 7, positive 7. That's greater than 2. Subtract 7 from both sides. We get 7x is greater than -5. And we divide by 7. Remember, we're not dividing by a negative. We're dividing from a negative. That's not the same thing. The sign's never changed. So x is greater than -5/7. Don't be too bummed about a fraction as an answer. When you graph this on a number line, it's not like I'd be asking my students to do much more than just put, oh, here's 0, here's a negative number, and it's -5/7, and I'm good. I just got to make sure I graph it with an open circle to the right, where 0 is included as a solution, and x can be any of these ones here. Okay, number 12 deals with fractions, but they're not bad with fractions because I can take 1/2 of 4 and 1/2 of -2 and not have too big of an issue with it. So number 12, 1/2 of 4 is 2, so that's 2x. I'm distributing, by the way. 1/2 times 4x, 1/2 times -2. 1/2 times -2 is half of -2, which is -1. So you get 2x minus 1. Distributing the negative here, -2/3 into 6x. 2/3 of 6 is 4. All right, and if you don't know how these things work, 2/3 of 6 is 2/3 times 6. And 6 is 6 over 1. So you can do it a couple ways. I'm just going to do a straight multiplication. 2 times 6 is 12. 12 and 3 times 1 is 3. 12 divided by 3 equals 4. 2/3 of 6 is 4. You can always do it that way through multiplication. If you must, for the sake of video time, let's keep going. But it's a negative times a positive, which leads me to a negative. -4x. Now a negative times another positive. 2/3 of 9 is 6. You know, think 3, 6, 9, you know, like that. And it's negative there, so -6. This is less than or equal to 4. 2x minus 4x can combine to -2x. You can imagine something we're going to have to do in this problem. -1 minus 6 is -7. This is less than or equal to 4. Add 7 to both sides. 4 plus 7 gives me 11. -2x is less than or equal to 11. Divide by -2, and when you divide by a negative, the inequality flips for the 10,000 paces east-west thing we talked about before. And I'll leave it as -11 over 2. -5.5. Okay, that's what that is about, greater than or equal to in that case. And again, you can double check. And remember, if you're wrong on your double check, you just go ahead and flip it over, trusting that you did the correct math leading up to it. Because of course, if you did incorrect math and placed it on the wrong side of 0 to begin with, you know, there's some issues with that as well. So you got to trust your algebra when you do this. So filled in circle because it's greater than or equal to. There goes x. Let's keep going. Number 13. What color? Let's go green. X plus 1 is greater than -5 times the quantity 7 minus 2x. Now this side is simplified, so I'm not going to do anything here just yet, but let's distribute the -5 into here. And we're going to get -35. Negative times the negative is a positive, so plus 10x. Okay, here's a new kind of problem in a different way, and I want you to think about this. I could potentially subtract 10x from both sides, and what I'll have over here is a -9x. I'll have a negative coefficient for my x, which means at some point I'd have to divide by a negative, and it could leave me with the issue of accidentally not flipping an inequality or not double checking right. Not me, just the idea of it. So you might say, well, okay, what if I don't subtract 10x from both sides? What if I look at my x term on the left expression, and what if I subtracted x from both sides instead and just made it a positive coefficient in my inequality? Does that work? Sure, you can do that. Let's check it out. Subtract x from both sides, and 10x minus x is 9x. Remember, that's really a 1x right there. So 9x there. I'm going to go ahead and add 35 to both sides right here already because I know I want my constants on the other side. 1 plus 35 is 36. So I have 36 here, and then that symbol, and a 9x here. Divide by 9, I get 4 is greater than x. Okay, I get 4 is greater than x. Now the solution's correct. I did nothing wrong. I kept the greater than, never divided by a negative, so the solution is correct. Here's where the problem comes. Graphing it. I'm going to do this in red for the wrong reasons when I need to do it for the wrong part. There's 4 to the right of 0. Here is the boundary point, not closed. And here is my drawing. I'm going to draw it to the right because this says greater than. All right, here's the problem. This does say greater than based on how you read it. We read these left to right. That's just how we read them. We say 4 is greater than x. I heard greater than, and in my mind, greater than means right. Hold your horses. This says 4 is greater than x. 4 is greater than some number. X is not greater than 4. 4 is greater than x. X can't be 5. X can't be 10. 4 isn't greater than 10. Something went wrong here, and the problem was reading this as greater than and automatically graphing right. You have to remember, here we're comparing a number to our variable. We're not comparing the variable to our number. So this thing is actually written the wrong way. And here's what I recommend for everyone out there listening. When you get your solution, make sure that you eventually write it with the variable on the left side of the expression. Always compare your variable to the boundary point. Always. And I'm going to always do it here. Even if I choose to do positives on the right side, guess what? I'm going to flip it over. And remember, if 4 is greater than x, that means x is less than 4 if you read this right to left. This is no longer greater than if you read right to left. X is less than 4, and that's how I'm going to write this thing. Basically, everything turns around. It's almost like I'm rotating this thing, only I can't change the 4 around. But see that? How the less than flips there? X is less than, I guess, h now. That's what's happening. Okay, that's what's happening. X is less than 4. So, we graph it to the left. Now, if you're not sure to do that, keep in mind, double check your 0 thing again. And I'm going to do it here because I have 2 different things with x in it. And guess what? With 0, they both go away anyway. So check this out. 0 plus 1, well, that's just 1. 7 minus 2 times 0, that's just 7. So let's try this and see if we get what we expect, a true statement. Is 1 greater than negative 35? Bingo. We're on the right track. If we graphed it this way, didn't expect 0 to be an answer, got a true statement out of this, then uh-oh, something went wrong. So something went right here. We did graph it on the correct side. X is indeed less than 4, as 0 worked. All taken care of. Okay, I think that's the extent of what I'm going to say as far as new teaching things and things to be cautious for. So given that I still have 7 more problems here, I'm going to speed burst through them. In a way, I'm still staying the steps. I caution you, but I'm not going to pause too much. I want to see if I can average this to 2 minutes a problem. Get to 40 minutes for 20 problems. Probably won't work, but remember I talked in the beginning as well. Okay, here we go. 5/3. Now, I could distribute it into these numbers, and guess what? I won't have fraction issues. I won't. But I want you to consider trying sometimes if you did have an issue. I'm going to write this again. I'm going to multiply both sides by a number that eliminates my fraction. If 3 is being divided, If 3 is being divided, then I can multiply both sides by 3. Now here's what it looks like. Times 3 here, times 3 here. 3 is already multiplying by the entire grouping because this is kind of, it's not one term, but it's acting as one term as it's a single product. These are two different terms, so this product needs to distribute into those parts here. See, this 3 divides by this 3 right here, and they're gone. No more fraction. But this 3 multiplies into both of these ones right here. So I'm not going to distribute that fraction anymore. I just got to distribute a 5 right into here. So let's see what we got now. This is not the way you have to do it, but this is the way I chose to do it. So here we go. 5 times 6x is 30x. 5 times 3 is 15. 3 times 2x is 6x. 3 times negative 3 is negative 9. All right. Now, your best of both worlds is if when I move this x term over, I have it positive and on the left side, and it seems like that's the case. That way you don't have to divide by a negative, or you don't have to flip your entire thing over from here to here. Flip. So, 30x minus 6x is 24x. I'm going to subtract 15 from both sides as well to move this one over here. Negative 9 minus 15 is negative 24. So 24x is less than or equal to negative 24. Divide both sides by the 24 here. It's positive, even though the answer here is negative. X is less than or equal to negative 1. That is my solution. Do you want me to graph it? Sure, let's do it super fast. 0, negative 1, closed circle because we include it. Let's go lefty, lefty. Now, it's probably at the point that you're like, okay, I get this video, we can stop. By and large, do it. Please. You only watch it as long as you need to. All right, take a look at this one. We have a negative 2/3 distributing into 4x and 4. This is exactly what I was talking about with that other problem. I'd much rather multiply by 3 on both sides here. I can't take 2/3 of 4 and get an integer. So I'm going to multiply both sides by 3. Times 3 here and times 3 here. 3 divides with this 3 right here. They go away, no more fraction. A negative 2 is going to distribute into the 4x and the 4. 3 here is going to multiply by 2x. So here now I have 6x. This is less than or equal to negative 2 times 4x is negative 8x. Negative 2, again, so negative, times 4 is negative 8. All right. I'm going to add 8x to this side to combine with that 6x. 6x plus 8x is 14x, and the negative 8x is gone here. That is less than or equal to negative 8. Let's divide both sides by that positive 14. I get x is less than or equal to negative 8/14. This can reduce to x is less than or equal to, divided by 2, negative 4/7. All right. Graph it. I guess this one's going to be in all black to match the color coding. Negative 4/7. Notice I'm not really ever scaling these. I just make sure that it goes on the correct side of the equation. The biggest reason, among anything else, is double checking your work the right way. Remember how I can, I never put an X here. Remember how I can check with 0? Right, so there's that. Okay, this one I'm going to distribute the 1/2 this time because, I want to diversify it. So 1/2 is going to distribute into the negative 2x and the negative 10. No fractions, not a biggie. And 3 distributes into the 4 and the negative 6x. Half of negative 2 is negative 1. So I have negative 1x, or negative x. Half of negative 10 is negative 5. 3 times 4 is 12. 3 times negative 6x is negative 18x. Okay. It looks like I can add this 18x over, and that'll get me in better shape because that'll leave me with positive x's on the left side. Good. On the right side, I'm going to have my constant, so I'm going to add the 5 over here. So these are gone on this side. These are gone on this side. Negative x plus 18x, that's the same as 18x minus x, which is 17x. 17x is greater than, oh, look at that, 17. 12 plus 5. Divide both sides by 17. X is greater than 1. For the sake of time, I'm going to stop graphing them. The point is you graph your solution anyway, and I think we've seen something like this, so I think you'll be good the rest of the way. All right, last 4. And I'm going to hit that 40-minute mark here in a bit. I'm going to go ahead and start with distribution because I got to start simplifying things. If they have x's inside of them, it's very important that I get them out in some way. This side is already simplified, so I'll leave it. Negative 5 minus 3x. This is greater than or equal to 20 plus 4x distribution plus 3. Don't forget that. 20 plus 3 is 23, so I'm going to have 4x plus 23 over here, and over here I'm going to have negative 5 minus 3x. Okay, on this problem I'm going to make the conscious decision to decide whether I want to subtract 4x and make them negative here, or add 3x and make them positive. Here's another thing you can consider. If you already know that's going to happen and you don't want to forget this later, flip it all right now. Meaning that, by that I mean put this expression on this side, put this expression on this side, and flip the inequality, because you need the alligator mouth to eat the negative 5 minus 3x, just like here. Now it's flipped. The benefit of this is now I can add 3x over, have it positive, and have it on the left side, and I don't have to think about any of that stuff anymore. I'm set. And that's what I'm going to do. Add 3x, subtract 23, all right? And now I have 7x is less than or equal to, this is a negative 28 right here, divide by 7, both sides, you get x is less than or equal to negative 4. Again, I'm not going to graph. I think you're making sense of it, hopefully. All right. Always trying something new, right? I mentioned before that instead of distributing, you are allowed to divide both sides by the thing that's multiplying here, as long as you think that it's going to benefit you, and here it wouldn't benefit me, actually, so I'm not going to do it. So I'm going to go ahead and distribute. The reason why I thought it was going to benefit me is because I thought I could divide 15 by 3, which I can, but I thought this number was going to be divisible by 3, which it's not. So I'm not going to do that. So let's distribute negative 3. We get negative 27x minus 60. And this is greater than or equal to 15x minus 20. Okay, so last time I decided to do a flip. This time I'm going to decide to deal with the negatives. I'm going to subtract 15x from both sides here. Okay? Now you get to make that conscious decision. That's your choice. Some people might not ever see it, that choice. So if you do, good on you. This is negative 42x. Negative 42x. And I'm going to add 60 over here. Big numbers. Plus 60. And this is greater than or equal to 40. So the numbers didn't end up getting that good looking here. That's okay. Now I'm going to divide both sides by negative 42. Negative 42. Because it's negative, west goes to east, west. And you got to go 10,000 paces the other way. Now you're further east than the person who just went 5 paces that way to begin with. So now x is greater than or equal to, I'm going to go ahead and, look, that was not intentional. X is less than or equal to, that's why you want to graph it. I'm going to reduce this fraction, that's what I was focused on. I'm going to reduce this fraction by dividing both of these by 2. I'm going to get negative 20 over 21. Close to negative 1. But not quite. Last two, let's distribute the 8. Here we go. 8 times a quarter, x. 8 times negative 3. And I'm going to distribute the 4 right here. So here we go. 1/4, 8 times a quarter is 8 divided by 4. So that's 2x. Minus, we're going to get 24 here. Minus 24. Plus 24, because that's still right here. And that's less than 4x plus 20. All right. Negative 24 plus 24 is 0, so they are gone on their own. I don't have to do anything with that. Now I have to kind of make that decision. Do I subtract 4x, make it negative? I'm going to, only because there's nothing else to move over here as a constant, and 20 is already over here. So let's subtract 4x from both sides. 2x minus 4x is negative 2x, and this is less than that 20 that remains. Divide by negative 2, x is greater than, 20 divided by negative 2 is negative 10. Notice the flip when we divide by the negative. Even if I didn't write it, whoop, there it is. Last one, here we go. Negative 2 distributes, let's use a different color. Negative 2 distributes into the x and the 2. Negative 3 distributes into the x and the 3. All right, let's see what happens. 6x minus 2x Plus 4 or minus 4? This one's minus 4. Negative 2 times 2 is greater than 2 minus 3 times x. Negative 3 times 3 minus 9. There we go. Let's combine like terms. 6x minus 2x is 4x. There's a minus 4 that remains. 2 minus 9 is negative 7. So I have negative 3x minus 7. Move things around. If I add the 3x over, I'm going to get 7x. If I add the 4 over, this will give me negative 3. Negative 7 plus 4 is negative 3. 7x is greater than negative 3. Divide both sides by 7. X is greater than negative 3 sevenths. Okay, so that was a lot of inequality talk. One of the longer videos, 45 minutes. My bad. Teaching is whatever. You know, I could have chosen half the problems, and it probably would have taken half the time, so that's fine. But I chose more. You got to see a lot of variety. Fractions, the negatives, the inequalities, number lines, double checking, word problems, and inserting them into it. So I hope all of it was of your benefit, and you chose to watch whatever it is you wanted to watch. All right, and look, that Yule log still burning bright, man. There it goes. That'll be it for this video. My name is Mr. Robinson. Please, if you have any questions, just leave them down in the comments below. I'd love to help you. And have a great, great rest of your day as I enjoy the great, great rest of my Saturday night.